Now this class we are going to discuss about the electric field intensity due to a charge sphere, because in the previous class we completed about wire of infinite length. The second one we completed about the ring, and we completed about the disc of different one, and sheets also we discussed some concepts. Now the sphere, in the case of sphere there are two types of spheres we can take according to the materials. One is conducting material, one is non-conducting material. So I taken the one of the conducting sphere here. That is, in the spheres also we have two types of spheres are there. One is hollow sphere, one is solid sphere. So first I taken the hollow sphere. So this is a hollow sphere. I given the charges to this one. So charges will be accumulated on the surface of this sphere, you know that. And where r is the radius of this one, the sphere having radius. The radius of the sphere is equal to nothing but we can write as r. So r is the radius of the sphere. Now in this case, what is happens here, in the case of I taken 3 points on this sphere. One is the point I taken as at the center. Second point is on the surface of the sphere. Third point is outside the sphere. Now in this case, to explain the concept of this electric field intensity at a point A due to the charge sphere. The point A is inside the sphere. When you taken the charge point inside the sphere, in this case according to the concept, this is a positive charge if we say, and this is exactly opposite positive charge. So to find the direction of the electric field at a point, we have to imagine a test charge, already I told. So imagine a test charge Q naught. Now this positive repels what direction? This is the direction of the repulsion here. This is the direction of the repulsion, right? So at the same time, the opposite charge also applies the repulsion force on that one from this charge to here in this direction. There is the equal and opposite repulsion force we get. Like that, every opposite charge repels each other, and the net electric field intensity at this point will becomes zero, because both are equal in magnitude, opposite direction, net will be zero. So like that, if you taken all the charges, net will be zero. So I can say simply electric field intensity is equal to zero at any point inside. So according to the concept of this one, electric field intensity at A. Okay, first if you are coming across clear approach of this one, first point I am writing like order wise. So first point, that is where distance of the point is less than radius of the sphere. In that case, the point will be at A. Okay, at A point, what is the electric field formula generally at any point? 1 by 4 pi epsilon naught, that is charge Q by R square is the formula for that. Now in this case, what is Q? Total charge of the sphere. What is R? Distance. Now in this case, if the point is chosen at the center, with respect to center only we are calculating the distance. So distance is equal to 0. That means I can say R equal to 0. R equal to 0 means electric field intensity also equal to 0. At what point this is? At A point. In terms of concept base, we can say electric field intensity is 0. In terms of distance also we can take 0. And not only that one, at any point also inside, at anywhere inside the hollow sphere, the electric field intensity always will be 0 according to the condition of this one. And go to the second point. What is second point? R is equal to R. That means the distance of the point I chosen on the surface of the sphere, small r equal to capital R. In this case, that is at B point. When the point is chosen on the surface of the sphere, in this case, the distance of the charges are on the surface. So here electric field intensity formula, if you apply, that is 1 by 4 pi epsilon naught. The charge on the sphere is Q by distance is small r square if you take. And what is small r value is equal to capital R. So I can write the formula in this case Q by 4 pi epsilon naught capital R square. So electric field intensity on the surface of the hollow sphere is equal to Q by 4 pi epsilon naught capital R square. So in this case, the distance of the charges on the surface we are taking as influence on the surface is equal to R only we are taking. Next, third point. Where is the third point? Outside. So third point is outside, means R is greater than capital R. That is at C point. Means if you chosen the distance of this point is equal to R if you chosen. In this case, so what is electric field intensity? The electric field intensity due to these charges will not become 0, because they are different charges are different distance. So electric field intensity at C point equal to 1 by 4 pi epsilon naught. The total charge is Q by, we are taking as a small r square only. We are not replacing with the capital R. Why we are not replacing with the capital R? Because here small r is greater than capital R. So small r is the effective distance compared to capital R. So I can write electric field intensity at the center, okay, outside of the halo sphere is equal to how much? 1 by 4 pi naught q by r square. This is for first case. Now in the case of solid sphere, this is the solid sphere we taken where all the particles are distributed across the volume. So there is a volume distribution of the charges takes place when it is charged. So whenever the charges are given, these are the charges which are accumulated on the complete volume of the sphere. So whenever the charges are accumulated on the complete volume of the sphere, in this case, we need to understand here. So what is the electric field intensity at a point? Practically, how much positive charges are there, that much negative charges will be there in the case of conductors. So what happens inside, the electric field will becomes equal to 0. Net electric field will becomes equal to how many positive charges are there, equal and opposite. Negative charges will be present inside the body. That's why always at first point, that is nothing but if r is less than radius, in that case at a point of A, so electric field intensity at any point is equal to formula based 1 by 4 pi epsilon naught total charge by square of the distance we can write, that is r square I can write. In this case, this value also becomes equal to 0. At any point inside the conducting sphere, the electric field intensity value will becomes equal to 0 because net charge will not be present there. Positive, how many positive charges are, that much negative charges will be there due to flow of nature of that material. Next, if we come across the case of second point, where is the second point I chosen? The second point on the surface. On the surface, whenever you choose all the charges which are inside, they are influencing on the surface. So here r is equal to small r equal to capital R, that is at B point. If you say electric field intensity at B point is equal to what I can write 1 by 4 pi epsilon naught, that is q by, I can write as small r square is a formula, but small r is equal to what we written, capital R. So I can write electric field intensity at that B point is equal to 1 by 4 pi epsilon naught, that is q by capital R square. It is similar like same like halo sphere. Everything will be, you'll get in the same manner as a halo sphere. Now come to the point of third point. Where is the third point? The third point is outside the sphere. This is at a distance of r from the center. The distance of this point is, if we say as r, at this distance now I can say r is greater than compared to radius is more. In that cases I can write as electric field intensity, that is at what point? At C point. Electric field intensity at C point is equal to formula based 1 by 4 pi epsilon naught, that is q by r square. So this is the equation of that electric field intensity at different points like inside, on the surface, outside at ABC. So main point conclusion here we have to do, okay, electric field intensity in the case of conducting sphere anywhere inside, either it is the halo or solid, that will be equal to 0. Now we'll discuss the graph related to electric field intensity due to halo sphere, conducting halo sphere, and conducting solid sphere. In the case of first halo sphere, in the case of halo sphere, so already you got the idea, inside anywhere the halo conducting sphere electric field intensity is 0. So in this case, from at A point is called center, there is no electric field intensity at the center. Up to what point? Up to B point. So inside completely there is no electric field intensity, that's why up to A to B there is no electric field intensity. Now at B point, what is the electric field intensity? We have a formula, that is 1 by 4 pi naught q by r square. So there is electric field intensity on the surface. So that value is not 0. So that means we are taking the electric field intensity at B point. Next, after that, what happens? Okay, outside the point, that is C point, whenever you taken the C point is at a distance of small r. C point is at a distance of small r from the origin. So in this case, the electric field intensity at that point will be decreases because distance increases according to relation, electric field intensity decreases. So in this case, the graph of this one will be, we have a curvature. The graph of this one, we have a curvature. That curvature we can represent like this. This is a way we can express the curvature of this one. This is a graph we can. So this graph indicates that, okay, electric field intensity here, it is inversely to square of the distance, we can say. The curvature which indicates that having some slope, that is due to inverse of square of the distance of that. Similarly, if we go to the next one for the solid sphere. In the case of solid sphere, inside anywhere, same like previous. What I said, electric field intensity at anywhere 0. So at the origin, that is A point, electric field intensity 0, up to the B point, the electric field intensity anywhere is 0. So, but at B point, there is electric field intensity. I am taking that point is here, the maximum electric field at this point, we can say that is electric field intensity at B point. And from B point to C point, again the distance increases, electric field intensity is going to be decreases. So electric field decrease in electric field intensity follows the curvature having certain slope. The graph of this one can be, we can take it like this. So in this case, what is electric field intensity? Electric field intensity inversely to square of the distance. So solid sphere or hollow sphere, the graph will be similar graph we are going to get here. Now we will discuss about the electric field intensity due to charged sphere, that is non-conducting charged sphere. We will discuss. First case is in the case of non-conducting sphere, hollow sphere. First, what is non-conducting sphere? Non-conducting means nothing but insulated sphere. Insulated means where there is no free charges available to conduct the current inside. That's why that sphere is called non-conducting material spheres we are calling. So here I take a non-conducting sphere, either conducting or non-conducting. Whenever you given the charges always accumulate on the surface. So here accumulated on the surface. I taken the 3 points from the center A point on the surface, B point outside is C point. Now the C point is a distance of r, B point is a distance of is equal to radius of the circle, and A point is at the center, that is equal to 0. So that means if condition, if r is less than r, that is at point A, we are calling at A. In this case, what is the electric field intensity at A point? Electric field intensity at A point is equal to, simply we can write as 0 because the distance is 0. So here you need to understand here either it is a solid one, sorry, it is a conducting hollow sphere or non-conducting hollow sphere. Electric field intensity anywhere inside will be always will be 0. In the case of, okay, which one, non-conducting hollow sphere or conducting hollow sphere. So go to the case of next one. So in the case of next second one, second point, what is the second point? On the surface. On the surface, what is that? On the surface means r is equal to exactly equal to radius of the circle, that is at B point. So what is the electric field intensity at B point? According to formula 1 by 4 pi epsilon naught capital Q by r square. R is nothing but equal to capital R, so I can write as r square. It is also same like conducting sphere. Both are same. That means some points the electric field intensity will be either in the case of hollow or either in the case of conducting or non-conducting. In the case of hollow will be same. Now this is the point of discussion we had. Now third point. So that means there is no change in the case of A and B. So third case is point is outside. Outside means it at a distance of r. So r is greater than capital R at C point. At what point? At C point. Now at C point, whenever you taken electric field intensity at C point is equal to, formula is 1 by 4 pi epsilon naught. The charge is Q by distance. What is the distance here? We have to take a small r square. It is same like. So here you need to understand in the case of hollow sphere, either conducting or non-conducting, the formulas or everything will be same. That means there is no change in the case of hollow sphere. In the case of conducting or non-conducting sphere, electric field inside will be 0, on the surface will be capital R square, outside will be decreases. The graph also will be in the same manner what we got in this one. Okay, this is a graph we can say for either conducting sphere or also non-conducting sphere. So I can write here hollow, this is for conducting sphere, also non-conducting sphere. Both are same graph only. Now we will discuss about the solid sphere, electric field intensity due to solid sphere at different points. First, I taken a solid sphere which is completely okay, contains the charges, the total sphere. Inside also there is the charges are distributed here. So here I chosen some points here, A point, B point, C point, D point. So first case, if R is less than R, that is at A point I am discussing here. At A point means, what is the A point? A is at the center. Center means equal to, almost we can take it as small r is equal to 0. At that position, what is electric field intensity? E is equal to, that is formula is 1 by 4 pi epsilon naught. Charge on this one is equal to, take it as Q by R square is the formula. In this case, this value will become equal to 0 because R is equal to 0. Total value will become equal to 0. Electric field intensity at a point is anyway 0. Now, if you come across the case of second one, where at the second point means that is at B point. If you come across at B point, R is that is equal to exactly R. D point we'll discuss in the last. R equal to capital R. In this case, I can write electric field intensity at B point is equal to 1 by 4 pi epsilon naught. That is total charge Q by. In this case, I can write as small r square can be replaced with capital R square. This is the electric field intensity at that B point. Now come to the case of C point. In the case of C point, same like previous. At C point, R is greater than capital R, so we have to replace with the smaller with the we have to keep the smaller in the same way. So electric field intensity at C point is equal to nothing but 1 by 4 pi epsilon naught. The charge is anyway total charge Q by R square. R square is smaller is the distance of that one, so we will take this smaller. So these are three formulas. Now our discussion is fourth point, where the fourth point that is at D point, capital D point. Okay, that is nothing but R is less than R, but it is not equal to 0. R is not equal to 0 at this position, at any position inside. How to solve this? To explain this one, first we have to understand here. So I taken a sphere. So on this sphere, the total charge is Q, already we discussed. This total charge is occupied across the volume of the sphere, so there is a volume charge density. In this case, electric field density will not be 0 at everywhere because it is a non-conducting sphere. That's why. So we have electric field intensity at this position of D. So the position of the D we are taking as at a position of position vector R we are writing. At what position? That is at a position vector R. Otherwise, we can write as a position vector that is a dr. Small position vector like also we can write. So to explain this one, first what I am doing is total charge distribution. What way the charges are distributed here? Volume charge distribution. Rho is equal to, that is nothing but formula based charge occupied per unit volume. Now what is the total charge? That is Q. Volume is equal to 4 by 3 pi R. If we solve this one, we can get the charge on the total sphere. Solid sphere is equal to rho into, that is 4 by 3 pi R cube. Why I am taking this one? Because now to explain the concept of which one in the case of halo sphere, that means sorry, in the case of D point, so we have to imagine a one of the sphere here. That sphere I am taking here like this. Imagine a sphere. Which sphere? In this case, this is one of the halo sphere, but having certain thickness, of that. So if you imagine that sphere, the sphere contains having certain thickness. That thickness is equal to, you take it as dr like thickness, and this is having radius. That radius is equal to, we can write as r. The radius of this one is equal to small r. You take it. Now we need to calculate this one from complete radius 0 to r. So that means I taken a small spherical ball. Example, like if you want to understand here, if you want to make a solid sphere, you take a small halo, very small point size halo sphere thickness. You take it like that. You arrange the number of halo balls. That the number of halo balls becomes into solid ball. So I taken a small part of that one. The small part contains how much charge? The charge on this one is equal to, take it as dq. So the charge on that one is equal to dq is equal to rho into, this is not having volume, it is having surface area, but it is having certain thickness also. That's why I can write the volume. This volume I can write in terms of, it is having surface area 4 pi r square into thickness is d. So this is the charge on that small sphere. Now this charge on the small sphere will be changes from 0 to surface of the sphere, that is capital R. So you have to integrate this one from 0 to r line. So for that, now take the formula for electric field intensity at any point formula, that is 1 by 4 pi epsilon naught. In this case, to calculate, this is the position, the D point is at a particular position. So you write the electric field intensity in terms of vector form 1 by 4 pi epsilon naught. The charge is dq by that is r cube into in the direction of the position vector we can write as r vector. Other in the form of r we can write that is nothing but the direction of r vector. We can write like this. So in this case, to solve this one, this is the vector in the direction of unit vector like if we taken. So now the electric field intensity is taken as dE. So integrate both the sides here. If we integrate this one, E is equal to 1 by 4 pi epsilon naught, take it outside, and here this small r cube, keep it like that. And now what I am doing is, what is dq? Write this one dq rho into 4 pi r square into dr by in this case denominator we have r cube is there, we can write as that is r cube. So denominator r cube you take it outside because we have to differentiate this one. In this case what I can write, E is equal to nothing but 1 by 4 pi epsilon naught into integral, that is I am taking the rho outside and 4 pi also taken outside, and the remaining is r square dr, that is r square into dr. This is nothing but in terms of distance of that sphere, that is nothing but in terms of r cube I can write as completely, that is we can write as capital R. So this we can write as r cube. So this is your differentiate from 0 to r like. If you take on this one, this we can write as rho into 4 pi. So 4 pi anyway we can cancel, no need to write again. So here you can check it directly. I'm writing here 4 pi get cancelled. So rho by epsilon naught r cube into integral r square dr formula is, that is nothing but we are going to get r cube by 3. Lower limit is 0, upper limit is r. If we taken in this case, to solve this one, E is equal to rho by this 3 is I am taking it outside, 3 epsilon naught into capital R. If you replace with r, that is r cube by r cube we are going to get. And also we forgot one of the unit vector, which is this is unit vector r cap, also we forgot that r cap you. So r arrow you take it outside, that is position vector, this is a fixed vector. So r vector, if you take an outside, this r cube get cancelled. So finally you are going to get that is rho by 3 epsilon naught into r arrow. So this is one of the expression you are getting, electric field intensity in terms of vector as rho by 3 epsilon naught r. If you want to calculate in terms of only magnitude, that is simply rho epsilon. So electric field intensity at fourth point, according to fourth point, electric field intensity at D point is equal to what I can write, rho by 3 epsilon naught into r. So what is our position vector? So as the position of the point changes, automatically electric field intensity also changes. So I can say here electric field intensity directly proportional to position of that point. This is important here. So inside anywhere the electric field is proportional to distance of that point, and outside the electric field intensity at C point, the electric field intensity is inversely to square of the distance. Now we are going to discuss about the graph related to this one for this solid sphere. Now come to the case of graphs. In the graphs for the case of non-conducting sphere of halo and solid. First halo sphere, already we done the equations at center, that is at A point. So what is the electric field intensity? Inside anywhere the halo, either solid sphere or halo sphere are conducting or non-conducting, what is the electric field intensity? 0. So electric field intensity is 0. So there is no electric field is present from here to up to the surface. Now at B point, B is nothing but on the surface. On the surface there is electric field present. There is maximum electric field, like we can take it. This is the way the electric field will be present on the surface, that is equal to EB. Now from surface B to C point, what is happens? The electric field is going to be decreases. Electric field is going to decreases as you are looking outside. It is going to decreases as you are looking like this. So in this case, the decrease of this one follows the relation as E is proportional to 1 by r square relation, it follows outside the halo sphere of non-conducting one. If we come across a case of solid sphere of non-conducting, we discussed that just before at the center, electric field intensity anywhere, at the center, electric field intensity anywhere, the distance of the point is 0. So in that case, either solid sphere or hollow sphere are conducting or non-conducting anything at the center is always 0. But in the case of non-conducting solid sphere, inside at any other point other than the center, electric field is not 0. In the case of conducting sphere, it is 0. In the case of non-conducting, it is not 0. Some value will be present. So that relation we got inside, what is the relation we got? Electric field is proportional to R vector we got. That means here we need to understand here the electric field intensity is directly proportional to position. So as the distance is increasing, electric field also increases proportionally. So I can take the graph of this one like this. Inside it will be graph like this. So up to certain distance up to the surface, we can say the electric field intensity will be increases proportionally to the distance. So now on the surface, if you come across a case of on the surface, the electric field intensity formula is same, 1 by 4 pi naught q by r square. R is the radius of that one. So here it will be maximum, that is equal to electric field intensity at B point. And if you come across the case of C point outside, the outside anyway it will be follows the same relation as any sphere outside, because electric field intensity decreases as you are going away from the charged body. So in this case, the electric field will be decreases. This point we can say here, right? So here we need to understand that electric field intensity is inversely to square of the distance of this. Inside the solid sphere, electric field is proportional to R. Outside, electric field is inversely to R square. Now this is the graphical understanding you will see. So in the case of conducting, this is the region from A to B. In the case of conducting or non-conducting hollow spheres, we got, okay, there is no electric field inside. But in the case of non-conducting solid sphere, we have electric field region that is proportional to R. This is the one point you must understand in the case of this. This is only the one different point. This is the graph is over about electric field intensity related to the concept of spheres. Now we will discuss about the neutral point and null point. Okay, concept, it is most important for the basic level of problems and understanding concept of the electrostatics. In this case, I taken two system of charges. We have a two, maybe three, maybe four, whatever may be the system of charges. According to the system of charges, this neutral point concept may be exist according to the type of charges which you choose and according to the place which you choose. So here I taken two charge system. Now these two charge system are separated by certain distance. Now you know that there is a certain force of repulsion between these two. It takes place from center to center. The distance between these two is equal to, you know, that R. Now there is a repulsion force is there. Now when there is a repulsion force, that means there is a interaction between them. So that interaction we can able to explain in terms of electric field concept. Now, so in the case of two similar charges, one is positive, second one also positive. If you take in the two similar charges, neutral point always exists in between these two charges. In between these two charges, along the line joining between them, That means in between means this is the line which you can see. So if the Q1 is equal to Q2, suppose if the charge Q1 is equal to Q2, both are same magnitude. In this case, you will get the neutral point at the center, exactly at the center. So how can you say the exactly at the center to explain? So at this point, what happens, what we can say here, at this point, at neutral point, there is no electric field exist. That means here, this imaginary test charge here, first the Q1 repels this one in this direction, the Q1 repels in this one in this direction with a electric field intensity 1. Now Q2 repel this one, Q0 in this direction. So electric field intensity at this point is E2. So two electric fields are present at the center due to both the charges. When these two values are becomes equal, that is in terms of magnitude, E1 is equal to E2, and both are becomes opposite. When both are becomes equal and opposite, net value will becomes equal to 0 at the center. That means E1 plus E2, the total electric field at the center, if it is becomes equal to 0, E1 plus E2 equal to 0, that means E1 is equal to minus E2. Then I can say that that point position is called as neutral point position or null point position. That means there is electric field, but net electric field value will becomes equal to 0. In this case, what distance you will get the null point to identify that? Theoretically, I can say that when you taken the two positive charges, null point will be always okay between the two charges will be taken between the charges always whenever you taken. Suppose if you taken one charge is positive, one charge is negative. In this case, null point always not between the null point will be always outside. Null point will be outside the charges. The null point will be outside the charges. One more point, this null point will be located along the line joining of the two charges only. Along line joining of two charges. That means whenever you taken the system of two charges, the null point will be always exist along the line joining of the two charges, either inside or outside. Inside will be only when both are positive, okay, and outside will be when both are one is positive, one is negative. In that case, the neutral point will be outside of the two charges, but along the line joining between them. That is the concept. So now we are going to derive the expression for what distance we will get the null point to calculate. If both are equal magnitudes, we got okay that null point is exactly at the center. If both are not equal, in that cases where you are going to get, if q1 is not equal to q2, in that case where you are going to get the null point. Theoretically, I can say that okay, the null point will be always exist. Null point always will get at near to the smaller charge. Near to smaller charge. That means in the case of q1, q2, which is smaller one, near to that one, we will get the null point always. Now we are going to derive the expression for what distance will get the null point in the case of two charges are not similar one. Now we are going to derive the null point expression. So if q1 is not equal to q2, q1 is not equal to q2, both are different. In this case, the null point position may not be at the center. So from the one of the charge, you take it as which is formed at x. Now we need to find the x formula in terms of that. So total distance between the two charges is r. If null point is formed from the first charge is at a distance of x, okay, then it will be formed at a distance of remaining distance of r minus x from the second charge. So using this, I can write. So this q naught test charge which you taken at the center, that will be repelled by q1 and q2. So at null point, the condition is E1 is equal to minus E2. Electric field due to the first charge is equal to second charge. So what is electric field due to first charge? Electric field due to first charge formula is 1 by 4 pi epsilon naught. The charge is q1 is repelling the test charge. Okay, that is q1 by r square. Square of the distance. What is the distance of the test charge? We imagine that the point is at a distance of x. So write as x square is equal to minus E2. E2 is the electric field due to second charge at the same point. So formula is 1 by 4 pi epsilon naught. The charge is second charge is q2 by distance. What is the remaining distance? R minus x. So I can write r minus x whole square. So now I can use the mathematical approach to derive the derivation. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught is get cancelled. So now I can write here this r minus x. I can write r minus x whole square by x square is equal to, I can write as q2 by q1. That means this I made into denominator, this one I made into numerator, so that the expression will becomes as you're looking like this. So in this expression, if you observe that, what we can observe here in the expression, r minus x whole square, x square, both are having square, so I can write r minus x by x whole square is equal to, I can write as q2 by q1. Now square, make it that side. So this expression I can write in terms of r minus x by x is equal to under root of q2 by q1. So our requirement to get the x value. So what I can write this, I can write as r by x minus 1, because r by x by x is 1. So r by x minus 1 is equal to under root of q2 by q1 I can write. So from this, what I can write, r by x equal to nothing but, okay, this is already we have, I think we have a minus, is there here, right? So minus, that minus, if I take in here, okay, that minus will be there. So r minus x equal to, if you make it that side, becomes plus. That means that is plus 1 it becomes. That means 1 minus under root of q2 by q1 I can write. q2 by q1 expression according to the minus if you take. So in this case, what I can write, x equal to r by 1 minus under root of q2 by q1 I can use. So here we need to understand the concept of derivation here. X equal to, that is r by 1. In the case of minus, I can use plus or minus under root of q2 by q1 is the formula for this. When you have to use minus, when you have to use plus, that is important for us. So if the two charges are similar, that means like charges, okay, if the two charges are like charges, that means plus plus if which is chosen. In that case, you have to use the plus sign, okay, you have to use plus sign. If both are unlike charges, you have to use minus sign in the formula. So x equal to nothing but, what is the formula, r by 1 plus or minus under root of q2 by q1 is the formula for this. This is expression for derivation of null point expression. In the case of similar charges, like charges, you have to use plus sign. In the case of unlike charges, you have to use minus sign. This minus indicates anyway direction. Based on that one, we derived here. Now next one, most important concept. This is very simple to understand. If you understand once, you can solve the problem, but it gives some confusion to some students if they are not understand properly. Equilibrium of system of charges. What is the meaning of equilibrium? Stability, stable. Practically, if you come across a case of two charges I taken, two charge system I taken here, one is q1, second one is q2, both are positive. What happens practically? Repulse each other. When they repulse each other, if you left it like this, what happens? They will go infinite distance both. Yes or no? So I want to make the two charges. So theoretically, up to now we discussed what is the force between these two when they are separated by a certain distance of r. We discussed as according to Coulomb's inverse square law, F is equal to 1 by 4 pi epsilon naught, that is q1 q2 by square of the distance between them. Like this we discussed. This is a force between the two charges. Now due to this forces acting on each one, that means first charge apply the force on this one, second charge also apply the force on this one. You can see the arrow mark direction, which direction the force is acting. So the two charges will be not in equilibrium. They are trying to move away from each other. If you want to make it equilibrium, so here concept is we are introducing a charge in between the two charges. Understanding? I am keeping the one of the charge, I am taking one of the charge, that is capital Q I am taking. So how much charge I have to keep it in between these two so that the system will be equilibrium. What is the meaning of this one? Q1 is positive, Q2 also positive, both are repulsing each other like two friends are fighting each other. This is example like. When the two friends are fighting each other, then what happens? It is required, if they are not understanding each other, they are repelling each other. In that case, middle person, one of the person is required, like this is Q. What that middle person will do? He will compromise both. He will compromise both, so that what happens? They won't fight each other. They will be again becomes as a friend, as a system. Here also same thing. We have to choose the Q value, so that what happens? The system of these two charges must be stable. Stable means equilibrium. That is called equilibrium of system of charges. In the case of two charge system, there is a charge required at a position, so that system will be equilibrium. In the case of three charge system also, charge required to keep it at a one position, so the system will be equilibrium. Like that we have four charge system. Okay, equilibrium condition can be explained using this concept of this. So to solve this concept, our requirement of main point is, what is our concentration to solve it here is, first both the charges are repulsing each other. Yes or no? This Q1, Q2 repulsing each other. So there is a force between these two. The force between the 1 and 2. The force between the first charge and second charge. that is equal to must be, okay, balances by another charge. That means this first charge, second charge is repulsing each other. How much force they are repulsing, that third charge which you are keeping, that has to balance. That means the third charge, what it will do, it has to bring the first charge and second charge together. That means suppose if we taken this capital Q has to, okay, apply the force on the Q2 such that it should not go away. What type of force it has to apply? Q1 is positive, Q2 is positive, so repelling. So whatever the capital Q you are taking, if you, what type of charge if you taken, so that it should not repel? Negative charge. That means capital Q must be negative charge. If you choose in the negative charge, what happens? Q2 will be attracted, not repelled. So due to that attraction, what happens? The charge Q2 will be in equilibrium. So how much amount of that you have to take? So that force between the capital Q and small q2 must be equal to force of repulsion between these two. That means the force between 1 and 2 must be equal to attraction force between the capital Q and small q. Right? In what direction? Both must be in opposite direction. One is repulsing, another one is attracting. So force between 1 and 2, repulsion force, must be is equal to force between the capital Q and small q. Now we are going to derive that capital Q is positive or negative. We can get it from this equation. So write the formula for 1 to 2. Between the charge 1 and 2, what is the force? According to Coulomb's inverse square, I can write as 1 by 4 pi epsilon naught. One charge is Q1, second charge is Q2. Now what is the distance between these two? R. So R square I can write is equal. Now what the force between capital K and small f? Okay, the force between these two is equal to 1 by 4 pi epsilon naught. One is capital Q, second one is small q, that is Q2. Okay, capital Q and Q2 by, what is the distance here? This is the distance here, right? Now where you are keeping, I want to keep anywhere, but now I am keeping this one exactly at the center, exactly at the center. So according to the position, you have to choose the magnitude of that one. So I chosen at the center point. Center point means I can write as R by 2 whole square. If you chosen like this, now I can able to solve it. Now you can cancel it. What I can cancel? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. Both we can cancel it here. Okay. So after cancelling, what I can take it here? This I can cancel, this I can cancel. Remaining is here R square. Here R square cancel. But there is a 2 is there. 2 square will goes up, and this will be goes to the denominator as a 4. So that I can write the expression as like this. If you write the expression for that one, what I can write, that is nothing but Q1 Q2 R square is cancelled is equal to 4 times of capital Q into Q. So in this case, what I can write, what is Q2, Q2, Q2 get cancelled. So that means capital Q is equal to what I can write, that is Q1 by 4. This is the charge you have to choose at the center. If the both are similar charges, in that case, I can write simply if Q1 is equal to Q1 is equal to Q2, in this case is equal to Q. In this case, I can replace that capital Q is equal to nothing but Q by 4. But what type of charge it is? Capital Q, that is negative charge you have to choose so that it will be attracted. So how much amount of charge you have to choose it here? That is minus Q by 4 charge if you choose them, so that the system of these two charges will be in equilibrium. This is called equilibrium of system of two charges. Like that we are going to do the problem in the case of 3 charges, 4 charges, like that. So I will explain the case of 3 charges in simple way. In the case of 3 charges, I am taking the one of the triangle, equilateral triangle. You can imagine if you take an equilateral triangle, I kept the charges here. One is Q, second one is Q. So these two repulse each other. These two are repulse each other. Now how much charge you have to keep it here at this point, so that the system will be equilibrium? How much charge you have to place it here, so that system will be equilibrium? Is it possible that or not? So the charge whatever you are keeping, it must be within the system of the two charges. So it is outside, it is not possible. So I can take the third charge also. Okay, I can take this also, small 3 charge system. In this case, I'm I am keeping one of the charge here, Q. How much charge Q you have to take so the system will be equilibrium? The concept is here, the three charges will be repulse each other. Three charges will be repulse each other. If you observe the repulsion of that one, these two repulse like this, these two repulse like this, and these two repulse like this, and these two repulse like this. Each two will be repulse each other. So if you want to make it stable, what I want to do is, so suppose this capital, okay, this small q, both are repulsing this one in this direction. Suppose if you take this is the way it is repulsing, if you say, that means the two charges are repulsing one of the charge like this. In this case, the resultant of these two, this is the force F, this is the force F if you taken, this is the resultant force you get, repulsion. So system is not equilibrium, that's why one of the charge will be repulsed with this force, either this charge or this charge, any charge. But I taken for this charge, it is going to be repulsed with the force of Fr. Now this force make the charge to go unequilibrium. So okay, it is going from the system. So make it equilibrium. The whatever the charge you choose in here, that must be attract that small. So what direction it has to attract? The direction of the attraction must be like this. This is the direction of the attraction is required for that. So that what happens, the system will be equilibrium. So the force of the resultant force which is making the system to be unequilibrium. Now this force making the system to be in equilibrium. That means the capital Q small q force must be equal to resultant force. Now if you apply this concept of this one, you can able to calculate this Q. Anyway, nature of this charge is anyway negative, that you have to know according to previous discussion. Always the repulsion between the charges must be balanced by attractive force, or attractive force of the system must be balanced by repulsive force. This is the concept you have to apply in the case of equilibrium of system of charges. Now we'll do the problems at the time of problems, so you can understand that one, the concept of how to solve it in the case of 2 charge system, 3 charge system, 4 charge system. The concept is repulsion force must be balanced by attractive force by the additional charge which you are taking to make the system of charges to be in equilibrium. This is the concept of that one. This is the most important concept. Keep it in mind and practice it on this. Now we'll have a discussion of a problem on equilibrium state of system of charges. Now one of the question here is given. 3 charges are given. One is minus q naught plus q minus 4 q naught. Separated by distance of the two charges is how much? L, if you say. L is the distance between them. They're asking the options here. If the charges are free to move, in this case, system is never be stable equilibrium. System is equilibrium when charge is q is equal to 4 by 9 q naught. System will be equilibrium when the distance between the two charges is equal to minus 1 by 3 L. Last point, system is equilibrium for more than one position of q. So here, if you observe this one, both are minus charges, minus q naught, minus 4 q naught. Both are not having same magnitude. So both repulse each other, right? So whenever you are keeping the one of the charge in between, so this is plus q I taken. Whenever you keep the plus q, what happens? The system will be try to be okay equilibrium due to attraction by the plus q. Already what we discussed here. So in this case, whatever it is equilibrium, it is not a stable equilibrium. There are different types of equilibrium conditions. It may be equilibrium system, may be equilibrium, but is not stable because there is a repulsion force, there is attraction force, both are there. So in between that, okay, attraction and repulsion, what is happening? The system will not be in exact equilibrium. It will be always a stable equilibrium condition. Never be it will be never be stable equilibrium. It is always in a from the main position it is going to change. So it is not system never be in stable equilibrium. So first option is, you can say, correct. Second option, if we come across here, system is equilibrium when q is equal to 4 by 9 q naught. So equilibrium means first here you take minus q naught charge here, and you take this is minus 4 q naught charge here, and both are separated by distance of how much? L is given, and we taken 1 plus q charge here. The distance of the charge is not given, you take it as x. So you have to keep this plus q so that the system will be equilibrium. So first they did not given the x value, but they are asking this q value is equal to how much? The q value is equal to 4 by 9 q naught. Then system will be equilibrium. Now if you see the third point, system will be equilibrium when the distance is, okay, what is the distance? Minus q naught and q. The distance between the minus q naught and q. That means the x value. The x value will be, if it is 1 by 3L, the system will be equilibrium. Third condition is, we'll check it there by verifying. So first concept is minus q naught minus 4 q naught repulse each other. So the force of repulsion we can write in terms of like 1 by 4 pi epsilon naught. One is capital Q naught, second one is 4 Q naught, minus of minus become plus, by distance between them is L square. Next, that force of repulsion will be balanced by force of attraction between, okay, the minus Q naught and plus Q. So in this case, I can write 1 by 4 pi epsilon naught. That one charge is Q naught, that is minus, into another charge is plus Q, by, I can write the distance of that one is x square. Now according to concept of this one, what is that? Force of repulsion must be equal to force of attraction. If you write that equation of this one, so anyway this is 1 by 4 pi epsilon naught, that is equal to 4 q naught square by L square is equal to, this is nothing but minus, that is q into q naught by 4 pi epsilon naught into x. What is x? Position of the charge. The position of the charge, okay, at equilibrium condition, what is the third condition given? 1 by 3L if it is. That means you take that one as 1 by 3L. 1 by 3L whole square means how much you will get? That is nothing but L square by 9 you will get. That 9 will be taken into the denominator. Now what I can write here? Now you can cancel 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. I can cancel here. 1 q naught get cancelled here, L square cancel here. So that means what I can write the equation for this one. In this case, I have only one q naught. Q naught is equal to, q is equal to, here we have a q, right? So we can write q is equal to, what I can write? That is q is equal to nothing but 4 q naught by 9 unit. So q is equal to 4 q naught by 9. So what sign you got? Minus. That means this, whatever the capital Q you are taking, that capital Q must be opposite of that one you have to take, that is plus charge you have to take. Minus into plus, that is equal to minus, minus of minus plus. So it is equal and opposite, so minus of minus becomes plus. So what charge you have to take? That is 4 Q naught by 9. So check it that one, that is 4 by 9 Q naught. So second option also correct. Now by putting the x value is equal to 1 by 3, we got the system is in equilibrium. So that means C option also correct. So the answer for the question is ABC. Now what is the last option? System will be equilibrium for more than one position of Q. One position of Q means in this case, according to these two charges, okay, according to these two charges, the Q value, whatever you got, 4 by 9 Q naught is only possible at one position. Remaining positions, the value may be different. For this value of 4 by 9 Q naught, the position is only one position. In the next video, we'll discuss about the force and electric field concept completely. Problems we'll discuss. But the complete video only contains the problems. Okay, nearly 30 problems we'll discuss in this, and after that we'll go for the next topic in the electrostatics.